Hey y'all, I wanted to go through a quick question here from WeBWorK. This is problem 3, and this is really about using the 68, 95, 99.7 rule for normally distributed things. So we have a question here, and it says that we know that men are their heights are approximately normal with a mean of 69 degrees and a standard deviation of 2.5 inches. So let's get ourselves a new workbook here in Excel, since I love my Excel so much. And I'm going to go ahead and think about what it means to be normally distributed 69 and standard deviation of 2.5. So 69 inches in height, 2.5 is my standard deviation. Okay, so when we talk about being normally distributed, with that as the mean and the standard deviation, what we really mean is that it follows this rule, 68, 95, 99.7. So what we'll say is that, the middle is that 69. But if we go down by one standard deviation, we will hit a special spot where, so if we go down or up by one standard deviation, we'll hit that special spot, and within here would fall 68% of the probability. It's also true that if I go down 2 standard deviations, so if I take that and subtract another standard deviation, that or go up by another standard deviation, that I now should recover 95% of the data. So 95% of the data should fall in here. Okay, so cool. That's just kind of what's going on here. Now, when I look at this, the first question asks what percent of men are between 64 and 66.5. Well, if in here represented in this interval here was 68%, that means that on this side would be half of it. Remember, it's going to be perfectly symmetrical. So let me stick a percentage in here. Half of 68 is 34. So 34% sits between here and here, and also 34% sits between here and here. Now, the next jump out, I need to go to 95. So to do that, I'm going to say, well, it was, so if I want 95 to be the total, and I had 68, 27% has to fall in these wings, right? And then I need half of that to fall just over here. So I'm going to do equals 27 divided by 2. And that would be the amount that would fall between this number and this number, which is actually what I'm looking for here. Okay, so let me go through this again. So under the normal bell curve, from the middle working out, if you go by one standard deviation, you get 68%. You go 2 standard deviations, you get 95, and it is perfectly symmetrical. Nice bump in the middle. So I start assigning how much is in between there. And I have to be careful not to assign stuff twice, right? So I didn't use 95 when I computed this. I did 95 minus that 68. And then I divided it in half to get that 13.5. By the way, let me go ahead and do it one more time. Let's go out 2, I've already gone out 2 standard deviations. Let's go out 3 standard deviations. That would be 3 standard deviations down, and this one would be 3 standard deviations up. If I do that, I've already placed 95% of the probability, and I need to place 99.7. So I have left 99.7 minus 95. I have left 4.7% of the probability to place, and I want to place each of that on either side. So I'm going to do 4.7 divided by 2. It's got to be symmetric. So this would be also equal 4.7 divided by 2. So in any case, now I've really filled it in, right? By the way, in the little wings out here, since there's 0.3% left in the wings, there would be 0.15. And I didn't leave myself enough room to put the 0.15 over there. But this is going out all the way out to infinity, right? Somebody could be really freakishly tall. If they're above 7'6", right? Did I do that right? 6'6", excuse me. They are pretty freakishly tall. There's very little probability of that. Same thing if you're below 5 foot. I think I'm doing those inches to feet wrong. I'm sorry. Let's just stick with inches, right? Okay, so what percent of men are between 64 and 66.5? Well, it's this number right here, this 13.5%. 13.5%. About 2.5% of men are shorter than blank. Well, that's this number right here. Remember, I could have put that extra little bit there. So about 2.5% are shorter than 61.5 inches. And what percent of men are taller than 69 inches? 69 was right in the middle, right? So it's actually 50%. 50% are taller than 69 inches because that was the mean. So we'll go ahead and submit answers, show you guys what I do wrong. 2.5% of men are shorter than, let's see. I made a mistake. Ooh. Oh, you know what I did? What I did was I said from here to here is 2.35%. I see. So I actually needed to use 64 here. So I just put the wrong number in. This number would have really few. It would. If I put in I used 61.5, guys. That was wrong. Sorry, 61.5 only has 0.15% of men being shorter than that. So the actual answer here was 64 because the way I'm counting things from here to here would be 2.35. I'm just counting things a little funky there. Okay, so I know this question is a little non-standard. I will say also too, guys, one of the ways I would do this in class is I would draw the normal distribution, the bell curve here. I didn't actually do that. I tried to do it with these numbers to show you guys how the numbers work. All right, keep studying hard. Keep going. You guys got this.